Hi guys, we are producing a proof where we are verifying left-hand side is going to equal right-hand side. Now say that the proof is in the pudding, and in this pudding here on the right-hand side is our objective and our outcome. And you might like to notice what's in it that can kind of help us form a strategy and a method on this side so we can achieve this objective. And that is, on the denominator, you might notice we have sine squared a. I want us to work with this side and keep in mind that we're going to put as many sine squared a's on the denominator on this side as we can. So first things first, let's see if we can focus on simplifying this left-hand side. One pattern I'd like to use that we use a lot in algebra is the pattern of a difference of two squares when we factor and when we expand. However, you might notice we have the power of 4. Now we can square root the power of 4 and it can turn to the power of 2. So we can do something like this. We could have cosec squared a minus cotangent squared a, and multiply that by cosec squared a plus cotangent squared a. Now that's a difference of two squares. Okay, next step is let's check out these cosecants that we have here and here. Now cosecant again is what? Cosecant equals 1 over sine theta, meaning we have the sine down below on the denominator, correct? So we want to have more of those because that kind of helps. Now you might be thinking, well, we've got cotangent. Isn't that got a sine on the bottom like here? Where's cotangent? Cotangent, cosine on sine. Yes, it does, and that could work, but a faster way is to have more cosecants all the way across. Why? Because there's a Pythagorean identity we can use. And it's this guy over here. It's the Pythagorean identity that goes 1 plus cotangent squared a equals cosecant squared a. Now all you have to do to make cotangent the subject is take the 1 and bring it over to the other side. So I'm going to do that. So I'm going to rub out this 1 here. There it goes. And I'm going to subtract it from the other side. So we just subtracted it from both sides. So we're going to take that and replace the cotangent right in there. So let's do that. So this becomes cosecant squared a minus 1. We're going to replace this one here with cosecant squared a, take away 1. So let's put all the other brackets around there. So this is going to be here cosecant squared a, take away, let's put that in brackets, and then the main brackets, and then again cosecant squared a plus, let's put brackets there and there, and close the brackets. So we've just replaced cotangent squared a with cosecant a minus 1. Okay, let's further expand and simplify these guys. So what we got here essentially, there's a minus this, and a minus will make a plus there. So this will become cosecant squared a, take away cosecant. And then a negative and a negative will make it into what? It'll be a plus 1, won't it? Close bracket. Let's do this side, cosecant squared a plus cosecant squared a, take away 1. So this is just take away 1 there. And close brackets. Okay, what can we do here? You might notice this blue cosecant squared a and this one here in red cancel each other because it's 1 minus the other. So let's get rid of those. They cancel, that cancel. That leaves a grand total of 1. So we have 1 multiplied by this over here. So you might notice here on the right-hand side, we've got 2 of them. So we can simply write 2 cosine squared cosecant. So 2 cosecant squared a, take away 1. There we go. We have that across there. 1 times that is simply that. Now, what can we do with this? Well, the cosecant, again, let's go back here. Cosecant equals 1 over sine. So isn't it true that we could write this out like this? We could write down 2 over sine squared a, take away 1, can't we? Now it's starting to look a little bit like that over there, but it's not quite there, isn't it? But we're getting there. We're on the right road. So how about we work this out using what we know from algebra and fractions. So we'll get a lowest common denominator, write them out as fractions. Lowest common denominator would be what? That would be sine squared a, wouldn't it? So sine squared a, that goes in that one time, so that'll be 2 times 1, which is 2. Take away 1, into that goes sine squared, so that'll be sine squared a over here. Sine squared a. Okay, so we got that fraction down there. So let's work with that. Let's bring it up over here. So what can we do with this to further simplify it? Well, the sine squared a, isn't it true that we can replace that with, because we have a trig identity, another one would be cosine squared a plus sine squared a equals 1. So what we can do to replace that sine squared a, because we want a cosine on the top, it's telling us, put a cosine there. So we can replace that sine by subtracting cosine from both sides, can't we? So let's subtract that cosine, take away cosine squared a, and over here take away cosine squared a. So that means if we take away these guys, they rub out completely, so let me just rub them out. So sine squared a equals 1 minus cosine squared a. All right, let's replace that with that over here. So let me just bring this up here and write it again. So we have from here 2, take away sine squared a. So let me write it up here. Write it up again, all over sine squared a. Okay, we're on the right road to get that right-hand side there. Okay, so let's replace this with that now, as we said before. So that's going to give us, that equals 2. Take away, replace the sine squared a with that. That's going to be 1 minus cosine squared a, close bracket, all over sine squared a. Let's simplify the top. That's going to equal 2. Take away 1 plus, that's going to turn to plus, negative and a negative there is going to turn to a plus. So that's going to be plus cosine squared a, isn't it? Now we can simplify that top part before we go to the bottom. Let me just write the bottom part, sine squared a. Now the top is 2 take away 1. Well, 2 take away 1 is just going to leave us 1. So the final answer looks like we're going to get this right-hand side. So the final answer is 2 take away 1 is 1. So therefore we're going to get equaling 1 plus cosine squared a all over sine squared a. And that looks like it's a match. Let's check it. 1 plus cosine squared a on sine squared. 1 plus cosine squared a all over sine squared. That is a match. Let me box it up. Hope that helps. There you go, guys.